Today we're going to be presenting our CP317 project done by myself, Michael, Tony, and Sahil. In this overview, we'll cover three main topics. First, the main classes and their purposes. Next, we'll walk through the core methods and data flow. Then we'll highlight the design principles at work. Our objectives are simple. We assign a single responsibility per class, which keeps each component focused and clear. This makes our code easy to maintain and test, since you can change or verify one piece without touching the rest. And by decoupling file I/O, business logic, and presentation layers, we've built in flexibility for future features. With that roadmap in mind, let's dive into architectural design. Here's our system's architecture. We've adopted a clean, layered approach to keep concerns separated. At the top is a user interface handled by grade calculator main.java, which deals with all the console input and output. Next, our file reader loads the two text files and turns them into student and course objects in memory. Once we have these objects, the grade calculation logic in the grade calculator class applies our grading formula. Finally, the program prints the story results back to the console. This simple four-step flow makes the code easy to understand and extend. If we wanted to swap in a GUI or database layer, we'd only need to replace the top or bottom layer without touching the core grading logic.
This UML diagram shows how our system processes students' grade data. We use abstraction, where data reader and data writer are abstract base classes inherited by student reader, course reader, and grade writer. The data processor class takes students and courses, matches them, and generates a student grade object using the grade calculator. Relationships show that a student is enrolled in courses, and each course ultimately results in a student grade. This structure keeps the system modular, reusable, and easy to maintain.
Alright, let's dive into detailed design of our grade calculator. First, I'll walk you through each of the core classes, what data they store, and what each method does, so you can see exactly how information moves from input files to final output. Next, we'll highlight the key methods that handle file parsing, grade computation, and result sorting. You'll see how data flows step by step through our system. By the end of this section, we'll have a complete blueprint of how our classes and methods work together under the hood.
Now looking over at some classes, we start to get an idea of the object-oriented principles being used, as well as what sort of attributes and methods we incorporated that follows our diagrams and gets us to our desired results. The student class represents each individual student and has private attributes such as the student ID and student name, as well as some basic methods such as the constructor and getters that we can use to display that information. The course class is used to store all the data that a student ID has taken with the course code, as well as all their test and final exam scores. The course class similarly also has its list of private attributes, the big one being the student ID that follows the same with the student class that we will use as a reference point to join the two text files together. It also has similar methods that we can use to get any needed information.
Here's the core logic behind our grade calculator. First, we load two lists, one of student objects and one of course objects, each holding scores for a single student. Then we loop through every course entry. We start by averaging the test scores and then apply our 60-40 weighing. 60% comes from the test average and 40% from the final exam score. That gives us the student's final grades. We sort each final grade in a simple map keyed by student ID. Once all grades are computed, we sort the entries by ID so the output is in a predictable order. Finally, we print each student's name alongside their computed grade to console.
Looking at our input-output system, we have our abstract base classes data reader and data writer that is extended by our implementations. Student reader and course reader both extend data reader, while grade writer extends data writer. This allows for a clean and simple structure which reduces code reuse, allows for more flexibility and scalability, and contributes to higher cohesion and lower coupling.
We use different data structures, including an array list, to store the list of final student grades, maintaining order and allowing fast iteration. We also use a hash map for quick lookup on student data keyed by their student ID, which speeds up processing when matching students to their courses. This makes the grade processing both efficient and organized. In our project, notable object-oriented pillars we used were inheritance and abstraction. Inheritance lets a class reuse and extend another class's functionality, and abstraction is the concept of hiding complex details and showing only essential features. These object-oriented principles improve code reusability, organization, and scalability, which are the core strengths of Java programming. Inheritance is used to let course reader and student reader inherit functionality from the data reader abstract class. This means they automatically get access to methods like validate file and validate line format without rewriting them. It promotes code reuse and consistency across different data readers, making the system easier to extend and promoting scalability. Data reader is an abstract class, and read data is an abstract method, which uses a generic return type T, allowing course reader to return a list of course objects and student reader to return a list of student objects. This approach is flexible and reusable, allowing each reader to provide its own custom implementation while sharing common logic, making this design clean, scalable, and easy to maintain.
Okay, now for the video demonstration of our simple Java command line interface project. We are taking two input files, course file and name file. We are sorting the data via student ID, and we are calculating the student's final exam grades or final averages based off this data. You can see here our input files are declared as a name file and course file, and our output file is declared as gradeoutput.csv. Now, before running through a sample execution, let's check out our name file. You can see we have a bunch of student ID numbers along with their corresponding names. And in the course file here, you can see the student ID numbers, the courses they took, their 3 test scores, and their final exam grade. So let's do a sample execution and see what happens. So as you can see here in the terminal, we read the data from our name file, read the data from our course file, and we successfully wrote the output to our gradeoutput.csv. If you look on the left-hand side here, you can see a new file was created, and when we open it, you can see all the data is displayed in this beautiful format, separated by student ID, student name, course code, and the final grade. So this part of the project is working just as we intended. Now let's look at some exception handling cases. Let's say we wanted to rename namefile.txt to something different. Let's say we choose nametest.txt. What would happen when we try to run the program now? As you can see in the terminal, we tried to read the data from the name file and we got an error. Error processing grades file does not exist, and it gives the exact file path location in which namefile.txt should be but isn't. So great, this is also working. Let's try something different. What if in our course file we added some invalid data? I'm going to copy this line here and paste it right under, and let's remove the final exam grade. What happens now when we try to execute the program? So as you can see here in the terminal, we successfully read the data from the name file txt, but when we try to read the data from the course file, there's an error processing the grades, and it says that there's an invalid format at line 51, expected 6 parts but got 5. So when we go back to our course file and we look at line 51, we can see that we had the student ID number, the course, the 3 test scores, but our 6th piece of info, like the final exam grade, was missing. So now let's briefly look at some of the code architecture. Here in this data reader abstract class, you can see we have an abstract method, read data. This method defines the template for reading any type of data. Like for instance, when we come over to our student reader class, you can see that it extends data reader, and it also overrides the read data function. Once again, in our course reader class, you can see it also extends our data reader class and overrides the read data function, adding its own implementation. So as you can see, this is a textbook example of inheritance and abstraction in action in a Java program. The abstract base class provides common functionality, like the file validation, while the subclasses inherit its functionality but add their own applications. This project demonstrates solid object-oriented principles like inheritance for code reuse, abstraction for clean design, and robust error handling throughout. The application successfully processes student grades while maintaining clean, maintainable code architecture.